Alright, welcome back everyone. So as you can see, this is where we left off in the last episode. We created a registration form, and when we insert some data into these fields and click the submit button, we process this form's request within our index.js route. And right now we are just processing it so that when we post all this stuff, that this registration title is changed to registration complete. So it should be noted, in between this and the last video, I have made a few changes. Within Webpack config, I noted in the last video that the Webpack config was already set up to compile ES6, but unfortunately I did not actually add that in there, I forgot. So between videos I made sure to add it in. If you'd like to make use of ES6 within your source, within your front-end JavaScript, then just go ahead and reclone the repo and try to match things up and get back up to speed. If you don't want to do that, not a problem. We're not going to be using ES6 within our source directory, so you can just keep going and using the current Webpack config you have from the last video. Another change I made was within our .getignore file at the very bottom. Excuse me, I didn't actually make this one. This was one of our viewers named Manuel. I think it's pronounced Manuel. Thanks a lot for this. He recommended and made a git push up to the git repo saying to ignore all .env files because we want to make sure that we're never tracking any of the credentials within this .env file because these are supposed to be sensitive pieces of information. We want to make sure that these are not public for viewing at all. So thanks a lot, Manuel. I really appreciate that. Super helpful. Let me know if I get that name pronunciation right. But that's a very, very useful tip for developing apps is you never want to track this .env file. And finally, the last change I made was within app.js. And the change I made was on line 13 right here. I added this line of code that requires a .env package. And this .env package, this is what is going to allow us to use the credentials within this .env file. If we don't have this line of code right here, then essentially all the credentials in here become useless because our app isn't processing the file. So pause the video, make sure that you add this line of code right here, and we will be good to go. This is the only line of code that you'll actually need to add from the last video in order to get the app working. It's not required that you add the .env or the ES6 code within the Webpack config, but down the line you'll probably want to. But for this tutorial, just go ahead and make sure that you're adding line number 13 right here. So going off of the process sheet that we created within the last video, let me drag it on over here. You'll see that we left off on step number 4, grabbing our form input and inserting it into the database. So like I said, we want to make sure that we're creating a user in our database over here. We want to make sure that we are creating a user so that when a user actually inputs their username and password into a login form, that we are comparing it against the username and password over here in our database. This is how we are going to start authenticating a user. If the username and password are both correct, then we're going to grant the user special permissions with a package called Passport, and that's where Passport comes in. It allows us to authenticate users, authorize them to access pages that they might not have access to otherwise. We can return data that is specific to them. That is the main point of what we're doing. We're creating a user in the database, and then we're using Passport to authorize our users to restricted pages. So let's go ahead and get started on continuing to create a new user in the database on step number 4, grabbing the form input and inserting it into the actual database. So we need to actually grab this form input within index.js. So the values that users type in here, such as a username, such as, I don't know, I'm cool, a username such as fsda.com, and a password. We need to make sure that we're grabbing these values, registering them within our post request here, and then we're going to write some code that actually pushes them up so that they're being stored as values over here. So in order to grab these inputs, we need to actually access them within the request object being sent up through the post request. So if I wanted to access this username input, I could simply access it by typing rec, which stands for request, accessing the body property. And the body property is created because we are pulling in this body parser package right here. It comes with the boilerplate by default, so no need to install anything extra. And then we need to access the input field's name. So if we look within our views file, index.handlebars, each of these inputs has a name associated with it. The username input has a name of username, and the email input also has a name of username, but we need to switch this to email because that makes more sense. Our password input has a name of password, and then our password match input has a name of password match. So these are going to be the names that we use to actually access each of the individual values over here. So we can access our username by typing request.body.username. And let's console log this out just to make sure that we're actually pulling it in. So remember, this route is only called whenever we're making a post request to a URL/register. So we actually need to fill this form out. We can just do dummy data right now. Make sure this is a little different. And if we want to view that this worked, we need to open up our terminal that's running nodemon. So I'm going to drag it on over here. And if we look inside nodemon, you'll see that we indeed are calling our body's username. We're console logging out the username, as you can see right here. If we were to change this to something else and submit it, you'll see that we're also console logging that out as well. And the reason this is being called twice, I believe it is because I have this open in 2 windows right now. Let me go ahead and search my other windows, make sure that I don't have it open, because BrowserSync might be refreshing the page automatically for us. And indeed I do. So over here you can see I have 2 registration pages open. If I drag this on over. So I'm going to exit out of this and just make sure that it's only being called once. Let's go ahead and test it one more time. And there you go. So you'll see that we are successfully pulling in the value associated with our username field. So we want to make sure that we're inserting not just the username, but also the email and password into our database. So we also need to be grabbing our user's email and our user's password. So to access the other two, like I said, we can select our request's body, and then we just need to select the name value of our individual inputs. So this would be email to represent our email input, and then this one would be password to represent our password input. So now if I save this, and we submit a form request to a URL of register, and this needs to be an email, so we're going to add an email there. You'll see that we're now processing our username, our email, and also the password associated with our forms. So we're successfully going from the front end of our site to the back end of our app. But now we need to actually take these fields and insert them within our database. So to do that, we need to make sure that we have a database connection, and we set this up within the last episode by filling out the fields over here. So these fields are being accessed within db.js. And these lines of code right here, the process.env, these just reference all of the values within the .env file. So this is successfully pulling this value right here, database host, database user is being referenced right here, database password is being referenced right there. And this is all possible because we added this line of code in line number 13 within app.js. If we did not have this line of code, then this wouldn't work. There would be no values associated with this .env property. So granted that all this information pertaining to our database is correct, we should have a connection whenever we require this db.js file. So let's go ahead and test this out. If I go inside index.js, I want to make a query to my database. I want to be able to access or insert data within my database. So in order to make a query, insert, or access data, like I said, we need to access this connection object right here. So to access that, we can pull it in by creating a constant called db. Constant is just a variable that is never going to change. We know this value is never going to change. We are going to pull it by creating a constant called db and requiring our db.js file. So to require this, we need to go down a directory since we're within our roots folder right now. So we need to go down one and then access it directly. So to go down one, we're going to type ... And to access it directly, we're going to say db.js. And with that in place, we should now be pulling in our connection directly into this constant called db. So to actually test this out, actually make sure that our connection is being created when we're pulling this file in, let's head back to db.js, and I'm going to paste a few lines of code in here that'll go ahead and test out the connection. So if you go to the mysql node.js git repo, which I have open over here, mysql.js mysql, and you start scrolling down, you're going to see that they give you some code to actually test the connection. So what we can do is we can copy this, paste it right beneath our connection, and so now when we're actually pulling this file in right here, we should see some information pertaining to our actual query in regards to whether or not it was successful. So let's go ahead and save this. And remember, this is only called whenever we're making a post request, so let's go make one really quickly. And let's see what our console says. Okay, so we are getting an error connection refused. So I will say, not all of you may be getting this. Some of you may actually be getting the correct result. But on some Macs, I have experienced this issue in which we have to specify another property within our connection here, our MySQL property, in order to get this working. What we have to do, we have to specify what the path to our MySQL socket is. And basically, this is just some extra information we need to specify how our app is connecting to MySQL. So this property is going to be called socket path. And if you're not getting this error, don't worry about this. But if you are, this is how you're going to fix it. You're going to be giving it a property socket path, and this property is going to be equal to the path of our MySQL socket. So to actually get the path for this, what we're going to do is we're going to open a new tab in terminal, and then we're going to type netstat-ln, create a pipe right here, and then we're going to call grep.mysql. What this actually means, I wouldn't worry about it. We are just trying to get the path. This is for a whole nother lesson. But let's go ahead and type that in, see what we get, and you'll see we are returned with a few paths. They all equal the same thing. And what we can do is we can just go ahead and copy the path and add it to our property like so. And let's go ahead and use single quotations. So now that we have this socket path in place, we should be able to connect to MySQL when we make a post request. So let's go ahead and test it out again, and this time you'll see that we don't receive an error, and we have a successful connection because we are running this query successfully over here. So now that we know we're actually connected, we can go ahead and comment this out for now. This might come in useful down the line in case our connection breaks later on. So let's go ahead and comment it now in case we need it. And let's head back on over to index.js. So let's go ahead and make a query that's actually going to post these usernames, these emails, and these passwords. Let's go ahead and make a post request that's actually going to insert these into our database. So to make a SQL query that's actually going to do that, we are going to access our database object, and we are going to call a query method on it. So the first argument within this query method is going to be all the SQL we're going to call to actually insert someone into the database. So to write SQL that actually inserts someone into a database, we are going to start off with insert into, and then we need to specify what table do we want to insert user data into. So to create a database table, we need to go back to SQL Pro, and we need to create an actual table within our database. You'll see I already have a table created, so let me go ahead and delete that really quickly, and we'll do it from scratch. So I'm going to delete this, and we're going to make sure that we're within our express.js database that we created within the last episode, and we are going to create a new table by pressing this plus button down here. And then we just need to specify a table name, so we are going to use users. And just like that, we now have a table name for our MySQL database. So like I said, we need to specify what table are we inserting this data into. So we're inserting data into the users table right here. Now we need to specify what kind of data are we actually inserting into this. So we need fields that'll represent our user. What kind of data do we want to store on each individual user? Well, we know we want a username, we know we want an email, and we know we want a password. So we need to actually create these fields using the MySQL program. And a word of disclaimer, most of the time when you're going about creating these fields, you probably won't want to use MySQL directly. It's okay for really small projects, but if you're creating something that's going to be scalable, you'll probably want to use something called database migrations. And what those are, they're basically files that you create within your app that when called upon, they'll go ahead and create all the tables, all the fields you'll need to get your database schema created. And the reason that we do that is so that we can store our database schema in version control, because if we're creating our fields over here and we accidentally delete our database and that's the only one we have, well, we have no way to actually track what our fields were, what their types were, what their lengths were, what tables we had, what their relationships were. There's no way to track all the stuff we had unless we had a backup. So that's kind of the whole point of database migrations, to ensure that we have a way to track our tables and the fields we're actually creating within our version control. But for the purpose of this tutorial, let's just go ahead and create our fields manually within SQL Pro. So to create our actual fields, like I said, we need a username field. To create a username field, we're going to click this plus button down here. Given that the users table is selected, we're going to click this plus button, and our field name is going to be called username. So each individual field takes a type, and this just represents what kind of data do we want to store within this field. So we can have things such as integers, which are numbers. We can have things such as strings. We can have things such as binary or dates. So a username, we want to make sure that this is a variable character, and that just means it can be letters or numbers. And the length of this field, you'll see that this is a length property over here. This is how long the actual field can be. So you'll see our ID can only be 11 numbers long, but we want our username to only be 15 characters long. And you might want to even go up to 25 depending on your app's need. The length of 15 I actually got from Twitter. You can't create a Twitter username longer than 15, or at least that's what I read within the documentation. And I can understand that because we want to make sure that we can display our users' usernames on the front end of our app without them getting too long. Because if there's something like 30, 40, 50 characters long, then they're just going to kind of break and not look good on our app. So 15 is a pretty good length for a username, I would say. Then we need to create a email over here. And this is also going to be a variable character. And a good length for this, I would say, is 100. Now, another disclaimer is, depending on your app, you might want to bump this up to either 150, 200, or even 254. And the reason for this is because sometimes services will generate emails which are 100 characters long or longer. But the instance in which that would occur is so very rare, and most of the emails generated over that long are probably fake, that 100 is usually a good limit. A lot of the emails you're going to get are going to be below 50 characters in length, but upping the limit from 50 to 100 is just there for safety purposes. So now that we have an email in place, we also need to create a field for our password. So this is going to be our password field. And this type is going to be binary, a little different. And the length for this is going to be 60. Now there are some very specific reasons why we're choosing binary for our type and our length of 60. You may be wondering, well, why can't we have a length that goes on to 200 or something even larger, maybe even 300? That's kind of pushing it a little bit, but why can't we extend our length past 60? And the answer to this is going to be for hashing purposes. Basically, the password the user submits, no matter the length, it's always going to be stored in our database as 60 characters long. And that is the whole point of hashing, is we're taking the user's plain password and we're basically putting it into a meat grinder of sorts. We're kind of grinding it up into the 60 character long password that is unreadable for specific purposes. So there's a lot to explain on this topic. I'm not going to go over all of it right now for time's sakes, but we will get to hashing as soon as we need to actually ensure that our app is secure and that we're inserting the user's password as we should be within a good developed app. Alright, so these are the three fields we're going to stick with for now. Down the line, you might want to add a registered at field to track when exactly the user was registered at for auditing purposes, but let's just go ahead and stick with these main three for now. These are the most important at the moment. So now that we have three fields in which we can actually store user content in, we now need to actually insert our user's content into this database. So we started writing our query. We know we want to insert data into the users table, but now we need to specify what kind of data do we actually want to insert in here. So the kind of data we want to insert is a username, an email, and a password. So now that we know what kind of data we want to insert, we now need to specify what are the values we're actually going to be inserting in here. So we're going to specify our values are the user's username, the user's email, and the user's password. So inserting these in here one by one is still attached to the request body object. It's going to get lengthy very quickly. So what we can do is, to decrease the size of these variable names, these objects and properties, we can assign these object properties to actual variables. So we're going to be creating a constant for our user's username by assigning the request body's username to it. And we're just going to do the same for other properties as well. So we're going to have an email variable called email, and we're also going to have a password constant called password. So now, rather than referencing these big, long, lengthy properties right here, we can just go ahead and reference the shorter version that we have right here. So we want to make sure that we're inserting a username, an email, and a password. But instead of referencing these directly like we are right now, what we're going to do is we're actually going to be referencing question marks. And you may be wondering, like, why question mark, question mark? Why are we actually doing this? Well, let me show you really quickly. The whole point of adding these question marks is going to be for escaping purposes. And what I mean by that is this is what's going to prevent the user from inserting any malicious code into our database. So we are going to reference over here. If we reference our values within an array as our second argument within this database query, the whole MySQL package that we're using to make our connection is going to escape our values automatically and protect us from any malicious data. So things such as script tags or any HTML that's being pushed upwards. So over here, we are going to reference that we want to push up our username. So we're going to copy that, paste it in there. So this first question mark is going to reference this first value within the array. So the second question mark is going to be our email, and the third question mark is going to be our password. So this will go ahead and write the query for us, but now we need to say what will happen when this query is actually complete. What will happen when we actually run this query? Will there be an error and we'll stop the program, or will the query be successful and will render a new page? Well, we're going to need instances for both in case the query does fail. So the first thing we're going to do is we're going to add some arguments over here to our callback function, and our arguments are going to be error, results, and also fields. So the main one we want to focus on is error. We want to say if there is an error available, or if an error has occurred within our SQL processing, then we want to make sure that we are throwing an error to the user. And all this line of code does right here, it says, if there is an error, we are going to return to the user an error and stop the app. So the next line of code we're going to write is we want to render our registration screen, and we want to return to the user a success message saying they have been successfully registered. So to return them to the registration page, we can grab this line of code up here that is occurring whenever we call a GET request to our index. So we're basically going to be returning them to the root of our site right now. If the root of our site was our register page, well, this is where we'd be returning them. We might want to change this to register down the line so that whenever a user gets a register page, they're actually returning to our form that's made for registration. But we'll probably do that down the line when we're actually optimizing our app. But for now, let's just go ahead, continue with where we're at. We're saying as soon as this database query, if it completes, we're not throwing an error, but we are going to render the registration page with a title of, let's just say, registration complete, as we have down here. We could have copied this code, I guess, but I didn't see it. Okay, so we are registering our index with the title of registration complete if we successfully insert a user into the database. We have all of our SQL code written out, so let's go ahead and test this out in the browser to make sure that this is working. So as soon as we submit our form, we should start seeing some data over here. Gonna refresh this, or let's just go ahead and visit it real quick. What happened to register? Okay, so like I said, when we make a GET request to .. that is when we get our registration page, not when we make a GET request to /register. So that's pretty much what it should be. We should be making a GET request to /register to get the registration page. So let's go ahead and change our / to register. And we don't want to register the index. We want to register our register page. So we're going to change all of our renders to register. And since we're changing our register view's name down here, we also need to change the actual name of the view within our views folder. So we're going to change both of those to register, like so. And let's see if we're getting our page now. There we go. So we've successfully changed the name of our register page to register. And let's go ahead and test out our database. Let's just insert some dummy data for now. So it looks like it went through. And I'm assuming we didn't have any errors, so let's go ahead and check out our database. And if we refresh our database, you'll see we now have successfully connected our app to a MySQL database, and we're successfully inserting data into it. So that's pretty cool. But since we are arduous and persistent developers who follow good coding practices, we are not done here just yet. Right now, if a user were to enter any data into this field, click Submit, well, they would register in our database as a new user, even if no information exists. And this is where validation comes into play. We need to validate that what the user is entering is valid data. So they should not be able to enter a blank username, a blank email, or a blank password. So in order to fix this, let's go ahead and look at our Node Authentication process. We have successfully completed step number 4 of grabbing form input and inserting in the database, but now we need to validate user input on the backend. And to do this, we are going to be adding the express-validation package. So express-validation package is basically a Node add-on that allows to validate the fields that are being inputted to our backend over here. So what we'll do is we'll ensure that the user's value over here for username, email, and password meet a specific criteria that matches up with our fields over in our database. So to actually make use of this package, we need to go ahead and open up our terminal and open up a new tab within your project directory. So our project directory is express-cc, and we are going to be adding a package called express-validator. So to actually install this package, you can use yarn or npm. The yarn version is going to be yarn add express-validator. Go ahead and submit that and let it run. It should be pretty quick. And to install this with npm, you're going to say npm install express-validator. And then you're going to add a -- save tag because npm doesn't save things to your package.json file automatically like yarn does, but this will still do the exact same thing as long as you add the -- save. So now that we have express-validator installed, we can go ahead and require it within our app. So to actually require this, let's go ahead and look at the express-validator documentation. We're going to open it up and scroll down a little bit and see how we can actually pull this thing in. So you'll see that they installed express-validator. Should probably have a -- save over here. But to actually pull this thing into our project, we're going to require this line of code right here. So we can copy this, head on over to app.js, put it in with the rest of our require statements, create a variable, And we want to make sure that we close this with a semicolon just to be safe. So now that we're actually pulling this in, there's one more line of code that we have to add to actually make use of this. And that is this line right here, app.use express-validator. And you'll see that this line must be immediately after any body parser middlewares. Look for our body parser middleware, which is right here. And right beneath it, we're going to paste that line of code in. We don't have any options that we want to set, so we're just going to get rid of this options array altogether. And if we save that, we can now make use of the express-validator. Let's go ahead and look at node.mod, make sure we're not getting any errors. I don't think we are. Let's refresh the page just to make sure. And I think we're good to go. So to get started using express-validator, let's head back to our routes file. And let's go ahead and pull it in here because this is where we're going to be explicitly validating each of our input fields. So we're just going to copy what we had over here in app.js, paste it over into index.js, and let's save the page. Okay, so now that we're actually pulling in express-validator, let's go ahead and make use of it. To make use of the express-validator, to ensure that the user's username, email, and password meet specific criteria, all we need to do is access our request object, and express-validator will add a function onto the end of that called check_body. So the first argument for this is going to be the name of the individual input field. So the name of our username field is going to be username. This is going to check whatever value is coming from username right here. And it's probably safe to store this above our constants right here before we're actually setting them. I'm not entirely sure if it'll make a difference if we place this below or above it, but it seems that if we place this above it and check our validations before we actually set our variables, that will ensure that we're definitely having 100% accurate data all the time. So like I said, the express-validator package will give access to this check_body property. It takes our input name as the first value. The second argument is going to be the error message we want to return if it doesn't meet a certain criteria. So we first want to say that our username field cannot be empty, because we want to make sure that a user cannot submit anything that is blank right here. And finally, we're going to attach another method onto the end of our check_body function, and this is going to be called notEmpty. This is also something that comes with the express-validator package by default. So if we save this, this is going to perform all of the checks, and if it finds an issue with any of the checks, then it's going to store that issue within a function called request_validation_error. So I'm going to go ahead and paste that over here. You'll see if it finds an issue with this, if it sees that the username field is actually empty, then it's going to return a validation error right here. And so since it's returning a validation error, we are going to be storing that error in a constant called errors. And we are going to be saying if any errors exist, we're going to log those errors in the console. But right now we don't actually have anything that ends this request. We're still adding a user to the database right here. Nothing is actually ending the request. So we are going to say if an error is occurring, then we are going to render a new view. And we can just say we're going to render the same view we're going to go to anyways. But this time we'll return a title of registration error. So let's go ahead and see this in action now that we actually set this up. You'll see right now we're getting an error in our console, and that is because we have an object right here, but it's not actually within object curly brackets. So we need to make sure that we're adding those in. Save the page. Let's see, make sure that we're not getting any errors. Looks like we're good to go. And let's go ahead and look in Chrome and see what happens when we make a new request. So our username should be blank. Our email is going to contain some dummy data. And if we submit this, let's see what we get. So you'll see before we even get to our SQL query right here that we are returning an error that says username field cannot be empty, which we specified right here. So that's the whole point of the express-validator package, to ensure that the values the user is pushing up meet certain criteria, such as not empty, such as should it be a specific length, should it match another field, and so forth. Now let's watch what happens when we get rid of this request validation. You'll see that if we open SQL Pro, we already have a user that has a username of no user. So I want to show you what will happen when we make another request to this. Just go ahead and insert dummy data like always, at least for the time being. If we submit this and refresh our database, you'll see that we now added another blank user. And even though we're preventing this over in our code, it should also be prevented within our database. This is something that the database can prevent as well. So to prevent this within our database, we want to make sure that our username and email fields are unique. So to make these unique, we're going to select our field right here, and we're going to click this plus sign at the bottom. And if we go up to key type and select a unique like so, you can see we have our username field selected right here, and we click add. You'll see that we are now getting an error that says an error has occurred while trying to add index. We have a duplicate entry for a key called username. So we're trying to make this field unique, but at the same time, we already have a lot of duplicates over here. So let's go ahead and clear our database just by selecting everything, hitting the delete key, and then we're going to click the delete button. So now let's try that one more time. Let's go ahead and select the field we want to be unique, hit the plus button, select the key type of unique, and then click add. So now we have a unique username in place. So our database will prevent a user from ever submitting a username of the same type. We want to make sure the same thing goes for our email. So we're going to select our email field, click plus, hit unique, click add. Now we have a unique username and email. So let's go ahead and try this again without our validation right here. Let's go ahead, refresh our page, insert a blank username. Let's just go ahead and type an email for now. Submit, and you'll see we have currently one blank username, which is okay because we haven't inserted our validation. But let's go ahead and try it again and see what happens. And you'll see that we're not actually refreshing the page like we were before. We're actually getting caught on something. So if we look within our terminal, you'll see that we have this big error up here. And if we scroll up to the top, you'll see that MySQL is actually returning an error of duplicate entry for key username. So even MySQL is preventing us from actually inserting a duplicate user. And this is going to be good down the line because we want to make sure that no user has the exact same username or email within our database. This is accurate data. That's the whole point of using a database in the first place. So now that we know our database has integrity associated with it, let's go ahead and uncomment out our validation over here. So to finish up this validation, I have a nice snippet copy and pasted, which I'll give to you guys as well within the description. And this is going to finish up any validation that we have associated with our actual app. So I'm going to paste this in right here, and you'll see that there are quite a few validation rules going on. But these are probably the best validation rules I could think of off the top of my head and also researching. So let me describe them really quickly before we move onwards. So you'll see that we're ensuring that our username cannot be empty. By appending this not empty method to the end of it, we're also saying a username must be between 4 and 15 characters long if a user tries to insert anything past that or anything beneath it. We're also saying that a user's email should be an email address. So this is a cool little method that express-validator gives us. It just ensures that the email syntax that a user submits is definitely going to be an email. We're saying that the email must be between 4 to 100 characters long. We're saying that the length of the email should only be between 4 and 100 over here. Same thing goes for our password. Our password should definitely be at least 8 characters because we want to make sure that we're not forcing the user to do something too long that might annoy them, but we want to make sure that their password is at least somewhat secure in the process. So upping the length of their password is usually good. If you really want to be secure, change this to 12, but 8 is probably the bare minimum, I would say, for any app. We want to make sure that our password inputted is no greater than 100, even though what we're storing in the database we have is 60. You'll see down the line why this doesn't matter. Just know 8 to 100 is usually a good limit. And then we're saying that a password must include one lowercase character, one uppercase character, a number, and a special character. And we're doing this through a regular expression. And regular expressions could be their own course, like their own series, basically. So rather than cover all of this, just know that this code right here is basically analyzing our password field. And it's analyzing it to ensure that we have at least one lowercase character, one uppercase character, and at least one special character. And we're also adding a little bit of extra validation on at the end right here by saying this should be at least 8 characters long. And finally, we have our re-enter password field. This is not what we actually called it. We actually called our re-enter password field, I believe it was password match. So let's go ahead and copy that. Go to app.js, or where was it? Index.js. Let's change this to password match. And we're saying that our password must be at least, our password match field must be 8 to 100 characters, and that the password match field must be equal to the password that's being submitted upwards to our app. So with all of this validation in place, we pretty much have very, very secure validation to ensure that the data we're pushing to our actual database has integrity, that is what we expect it to be. So we currently have a way to track a lot of errors if they occur. But right now, we're not actually returning anything to the user that indicates these errors besides this console log statement and this registration error. And right now, really only we can look at this console log statement because it's happening on the back end. We want to make sure that we're returning to the user a few errors that they can actually display. So to return the user a few errors, we're going to add additional data to our register route right here, to our register render. And this is going to be called errors, and it's going to be equal to our errors object that we're passing through. So let's go ahead and view what kind of errors we can get when we make a request that is not validated. So let's just insert dummy data that we know might not be correct. These are going to be bad passwords. They're not going to match. Let's submit. And let's look at our console to see what errors we're getting currently. So if we scroll down, you'll see that our error object contains the following information. So we have parameters for all the names of the field, and then we have messages associated with them. And these are the messages we want to return to the user. So to actually return these to the user, what we're going to do is we're going to render them within our actual view. And I think I just accidentally saved a piece of code that was not correct. Yeah, I accidentally commented this out, my bad. So we are going to render these errors within our register.handlebars view. So to actually render these errors, right now what we're doing is we're passing them through whenever we render it, as you can see right here. To actually render these within our view, we are going to be creating a new div, or actually, let's just start out with the handlebars syntax. So to actually loop through each of these individual errors, we want to say only display the following content if errors exist. And we can do that with the following syntax. We want to make sure that we close out our if statement. And then we want to loop through each of these individual errors. And we can loop through each of these by saying, for each error, for each of the errors associated with our errors object, and let's make sure that we're ending our each, we want to access each individual error's message. So you'll see, let's see, I have another error here, it looks like. And this is mysql error. Looks like I accidentally submitted the form for our database over here. Let me go ahead and get rid of these really quickly. And I want to make sure that our form is here. Okay, cool. See if our app is running. Let's go ahead and restart our app manually with Nomon. Revisit the page. Okay, there we go. So now that we have this here, what's happening is I want to make sure that we're getting that error that displayed all of our messages out, all those incorrect messages. So what's happening here is each of these individual errors that start with param, you'll see they're wrapped in their own individual object. So this represents one object right here. And if we keep going, this represents another error object right here. So what we're doing is we're looping through all of these objects as specified through the each, and we're accessing each of these individual objects message property, as you can see right here. So this is just a connection to this. And if we loop through all of these and display them out on our view, you might have seen a little preview. We're actually listing everything out right here, all the errors associated with our user's validation. So this is kind of hard to read right now, so let's go ahead and go back to our Bootstrap documentation, and let's add an error class to these fields. So to do this, head over to documentation, and I believe it is called alert within the search box. Yep. And we're just going to scroll down. We're going to grab the class for red because that means the user has some problems associated with their forms. We're going to grab that. And then we're going to wrap this message in a div that contains that class. So just like so. And let's make sure we're wrapping it. /div. And now if we save this and refresh the page, actually it should be refreshed automatically thanks to browser sync, you'll see that we have all of our registration errors in place. So you can see right now we didn't insert a username because it was empty, so it's returning to us that specific error. Our username should be 14, 15 characters long, and so forth. So let's go ahead and actually try to insert a user that meets up with our criteria. So our username, let's make sure that's between 4 and 15 characters long. It's going to be my name. An email, let's just do chris@gmail. It's not my actual email, but you get the idea. Our passwords should both match, and they should also contain a uppercase character, lowercase character, a number, and a special character. So I'm just going to add something over here. I don't really know what I'm adding, but let's just go with whatever. Actually, I got to remember what I'm adding because I need to type it in the next one. Let's do a bad password. Bad password is QWERTY1! Perfect. QWERTY with a capital Q, 1! So if we do this and submit, hopefully everything goes through without issue. It doesn't look like it is. Let's check out terminal, see what we have going on here. Alright, so we're getting another SQL error thrown to us. refresh the page. Somehow the username with somehow a blank username got through. So let's go ahead and delete that. Head back on over to index.js. We are indeed selecting our username. Let's just make sure our SQL database is empty. I want to restart Node to make sure we're getting a clean slate. So nodemon. All right, I'm going to revisit the page. And I want to make sure I'm not actually creating a user. So somehow I'm creating a user automatically, even though I have no values associated with the information over here. So I'm going to actually exit out of that page right there. Okay, so this may be due to the async nature of Node, I believe. So let's just make sure that we're only running this code down here. We're only running it if this is absolutely not true by adding an else statement. So let's go ahead and grab this, paste it within our else statement, save that, and let's go ahead and refresh the page one more time. Make sure that nothing is getting through thanks to our validation. So we're saying if validation errors occur, render this. If they don't occur, go ahead and insert them in the database and render this instead. So if we submit this, okay, we're getting all the validation. As you saw last time, we inserted a blank user, but if we refresh this time, I think we're good to go. Let's go ahead and delete this blank user and test it one more time just to be safe. And if I go ahead and refresh our database over here, okay, you'll see that now we're good to go because we added this else statement. This is only absolutely occurring if no errors exist. And let's one more time for safekeeping, safe measures. Let's go ahead and make sure that when we insert a legit user over here, I know this doesn't look very legit, but if we insert a legit user over here, that we are indeed storing that user in the database. I want to make sure that I include all the password requirements. And I believe that's it. There we go. It passes through. We refresh the page, and we now have a user in our database along with our first user. So that is how you insert data into the database safely. Make sure that we're not inserting any data that we might not want inserted in here in the first place. So I know this is a long tutorial, and there's a lot that goes into this in the first place. You may be a little overwhelmed. I hope I'm doing my best to really explain these hard to understand topics to you guys in the first place, because this is something you need to understand for pretty much every app you create. And there's a lot that goes into this, but it's very important that we get this right in order to ensure that our app doesn't get hacked, in order to ensure that our app works, in order to ensure that our business is functional and doesn't break and down the line due to bad coding or bad technical processes. So we are pretty much almost done with inserting user in the database. We added the express package right here. We have validated user input on the back end. But now we need to actually validate our user input on the front end, hash our user's password, and store the user's password in the database. So I think we're actually going to skip over validating our user's input on the front end. And what I mean by validating our user's input on the front end is ensuring that when a user is typing content over here, that we're giving the users real-time feedback and messages explaining how long their username should be, what their email should be, what password requirements should their password be using, such as a special character, a uppercase character, or a lowercase character. That would be front-end validation, just so the user knows that they're getting feedback real-time in regards to what they're typing in. But we are going to be focusing on number 8 and number 9 because these are the two most important things for storing a user in the database. So right now you see our password is available in plain text, and that means anyone who visits our database, anyone who's able to get in here, any database administrator, can view anyone's password associated with our site. And this is very bad for a few reasons. Mainly because if a hacker gets in here and is able to view all of our users' passwords, well, users tend to use the same passwords for different accounts. So if they're able to view one of the passwords within here, well, they can go ahead and test the user's email on a different account, maybe such as Facebook, maybe something such as Twitter. They can test the email and password out on there and potentially log into their social accounts. Not only that, but also their bank accounts. Anything that you might want very protected, they might have access to, which is very, very bad. So to fix this, we are going to be doing something called hashing a password. And basically what that means is it's going to change the user's password into a long string of characters, something really crazy like this that's 60 characters long. And the user will still be able to log in using the password, QWERTY1, that they had in the first place. And this is a very bad password, guys. Don't ever use a password of QWERTY1. This is just for demonstration purposes, something really quick that we can get in here. People will crack this very quickly. This is like one of the most used passwords across the nation or the world, if I'm correct. Don't ever use it. It's just bad. You're going to get hacked if you do. I'm not saying you're going to get hacked, but there's a good chance you'll get hacked. So in the next episode, we are going to focus on security by hashing our user's password, storing it in the database, and we'll completely finish creating a new user in the database. After that, we'll head on over to logging a user into our app. So what that means is giving the user access to pages that they might not have access to otherwise and presenting them with sensitive data that is meant for only them. This is where authentication and Passport comes into view. So I know it's a long tutorial, guys, but like I said, it's very important that we know how to do all this correctly from the start. If you have seen any slip-ups on my end, feel free to comment and say, okay, I think it's more important for the users to know what is correct, the correct way to create an app, rather than me trying to act like I know everything, because I promise you I don't. I just learn a little bit day by day, a little bit at a time. I'm just like you guys, I promise. It's just I want to make sure that everyone is creating apps the safe way instead of the wrong way, and me having a little ego boost saying I'm always right or so forth. So that's going to be it for this one, folks. I hope you enjoyed. I know it's a long one, but I look forward to seeing you in the next episode, and let's keep going and create some badass apps. Later.